Okay, so let's have a look at this whole logic problem. We're basically given this piece of code here called log, and what does it do? It basically loops while 3x is less than a, you increment d by 1, and then you multiply x by 3. And we'll keep doing that until this condition no longer holds. So we're given that we want to use whole logic to prove this property here. So the first thing that we do to try and find the invariant is we write down the table of values during execution. So we're given after executing 0 loops, d is 0 and x is 1. So what happens? During the first loop, we add 1 to d, so d is now 1. I multiply x by 3, so x is now 3. We add 1 to d again, so it's now 2. X is now 9, which I'm going to write as 3 squared. D is 3, 3 cubed. D is 4, 3 to the 4. Okay, so that's the table of values as the code executes. Okay, so now based on those values we've computed, we want to try and find an invariant. So we need to try and find some property I that's always true as the code executes. So if I look at the table, it looks like x is always equal to 3 to the power of d. So I'm going to guess that the invariant I is equal to, what did I say? D is, 3 to the d equals x. That's going to be my guess for the invariant. Okay? Now it is certainly an invariant in that it's always true as the code executes, but it might be the case that it's potentially not strong enough or not weak enough for the other two properties to be the case. The other two properties that we need is it needs to be strong enough to imply the post condition if the loop condition is false. So I and not B implies post condition Q, and we need to be weak enough that's implied by the precondition. So precondition P implies I. So let's look at the first rule. So what's our loop condition? It's given here. 3 times x is less than a. So in this case, not b would be the same thing as the negation of that, which is 3x is greater than or equal to a. So let's have a look at the property in question. I need x is equal to 3 to the d, that's my invariant, and 3x is less than or equal to a needs to imply my post condition. What's my post condition? 3 to the d is less than or equal to a. So let's write that down. Now, is it the case, if I know x is equal to 3 to the d, and 3 times x is greater than or equal to a, is that enough information to get 3 to the d is less than or equal to a? Well, probably not, because there's nothing stopping 3 to the d from being as large as possible, because all we know is that 3x has to be at least this big, but it could be like tremendously large. So my invariant here is unfortunately too weak. So this is no good. So what can I do? I need to strengthen my invariant. I need to think, what's the weakest, most minimal thing I can add here to my invariant, such that together I have sufficient information to imply the post condition. So one potential guess could be x being less than or equal to a. Because if we had that property, then I know that 3 to the d would be less than or equal to a, and then I would get what I want. So first off, is this even an invariant? Well, we know that the code only runs if 3x is less than a. If 3x is less than a, then that tells me x is less than a on 3. And if x is less than a on 3, then surely that implies x is less than or equal to a. So it looks like certainly it's strong enough to get what I want, but potentially it could be too strong. So we better check rule 2 as well. So rule 2 says the precondition, d is equal to 0 and x is equal to 1 and a is greater than 0, has to imply my invariant. And my new invariant is now x is less than or equal to a and x is equal to 3 to the d. So does that check out? If x equals 1 and a is strictly greater than 0, well, that's the same thing as saying a is greater than or equal to 1, then these two facts here give me that x is less than or equal to a, because x is 1 and a is at least 1. So that's good. And also we have that if x is 1 and d is 0, well, 3 to the 0 is 1, so we also get that x equals 3 to the d. So it looks like the correct choice for the invariant is x is less than or equal to a and x equals 3 to the d.